as we tend to believe, humanity is probably the most advanced civilization on Earth. Among all the exoplanets we have investigated so far, it seems we are also the only intelligent life forms currently in existence. But what if our advanced civilization is just one among many, some that might exist in the distant future, or may have even existed long before us? This idea is referred to as the Silurian Hypothesis, which was introduced in 2019 by Gavin Smith and Adam Frank. Their aim was to make us reflect on how self-centered and unaware we are in our quest to discover advanced civilizations. We usually assume that no civilization in the past could have matched our level of advancement, often overlooking the possibility that evidence or fossils of ancient advanced civilizations might go unnoticed. Imagine if our entire human civilization were wiped out tomorrow due to a pandemic, a natural disaster, or some other catastrophic event. What are the odds that civilizations arising millions of years later would even recognize our existence? Would they acknowledge that we had been an advanced civilization? Some might argue that humans have left behind massive man-made structures and non-biodegradable plastics, leaving a significant mark on Earth. Surely these would serve as evidence of our advancements and existence in future fossil records, right? Well, it's more complicated than that. Allow me to explain. Dinosaurs ruled the planet for over 150 million years. Their numbers were in the trillions, yet the number of complete dinosaur fossils discovered is almost negligible. This is largely due to the movement of tectonic plates. Most ancient land surfaces have been buried deep underground, with very few, like the Negev desert in Israel, dating back 1.8 million years, still exposed. Fossilization itself is an extremely rare process requiring very specific conditions. Take the T-Rex for example. This species dominated the late Cretaceous period roughly 66 to 70 million years ago. With an estimated population of 2.5 billion T-Rexes across at least 127,000 generations, only 32 complete fossils have been found. That means only one T-Rex fossil exists for every 80 million individuals. So, what are the chances of discovering fossils from a civilization that might have existed 100 million years ago? Fossils are formed from organic materials like bone and carbon, and their formation requires very precise conditions. In the same way, if humanity were to disappear, would future geologists find enough evidence of our existence 100 or 200 million years from now? Although the human population is close to 8 billion today, only 14.6% of the Earth's land, an area roughly the size of Russia, has been modified for infrastructure or agriculture. Furthermore, organic materials like human bones and teeth are not dense enough to withstand millions of years of degradation. Humanity's presence on Earth has also been relatively brief, spanning just 3 million years, with significant technological advancements occurring only in the last 300 years. If future generations relied solely on fossil records, the evidence of our existence would be nearly undetectable. This is why indirect methods of discovery would be vital. For instance, the vast amounts of carbon we've released into the atmosphere from burning fossil fuels could serve as a crucial clue. Unlike natural sources of global warming, such as volcanic eruptions that emit heavier carbon isotopes, C13, fossil fuels release lighter isotopes, C12. By studying ancient ice cores containing trapped air from periods of sudden warming, future scientists might distinguish human-caused global warming from natural events. Another indirect indicator lies in ocean sediments and marine organisms like oysters. These creatures store isotopic records in their calcium carbonate shells. During periods of global warming, lighter oxygen isotopes, O16, evaporate more easily, leaving a higher concentration of heavier isotopes, O18, in the shells. By analyzing the growth patterns of these shells, scientists could identify periods of extreme climate conditions. Additionally, human activities have created distinctive sedimentological markers. For instance, the use of artificial fertilizers has significantly increased nitrogen levels in coastal waters, leading to hypoxic dead zones where sediment layers are preserved for millions of years. Synthetic compounds like CFCs, rare earth elements, and radioactive isotopes such as plutonium-244 and curium-247, if found in unusually high concentrations, could also indicate an advanced civilization. To conclude, if future civilizations aim to uncover evidence of our existence, they will need to focus on 4 primary indicators: a decrease in C13 isotopes relative to C12 higher concentrations of O18 in marine calcium carbonate hypoxic dead zones in aquatic environments, and the presence of synthetic or rare elements in soil layers. However, such phenomena have occurred naturally throughout Earth's history. For example, during the Paleocene-Eocene thermal maximum, approximately 56 million years ago, global temperatures rose by 5 to 7 degrees Celsius over a span of just 5,000 years. While some scientists attribute this to volcanic activity, the unusually high metal concentrations from this period spark questions. Could this have been the result of an ancient advanced civilization? The Silurian Hypothesis, as Adam Frank emphasizes in his Atlantic article, is simply a thought experiment. It's an intriguing lens through which we can approach the search for extraterrestrial intelligence. Advanced civilizations that coexist harmoniously with nature are more likely to survive longer, leaving behind more lasting evidence. On the other hand, unsustainable civilizations tend to self-destruct, leaving only fleeting traces of their existence. What are your thoughts, friends? Do you think the Silurian Hypothesis could serve as an effective approach to uncover advanced life forms, or should our search focus exclusively on extraterrestrial life? Share your opinions in the comments below. Personally, I believe the likelihood of intelligent life existing on Earth before us is slim, and our focus should remain on searching beyond our planet. But that's just my perspective. What's yours? If this video brought you something new to think about, don't forget to leave a like.